All right, I'd like to welcome everyone to another installment of our Sustainable Energy Seminar Series from the Wisconsin Energy Institute. If this is your first time joining one of our programs, my name is Scott Williams. I'm the Education Manager for the Wisconsin Energy Institute and the host of the seminar series. The Sustainable Energy Seminar is held every other week in the fall and the spring, and our goal is to highlight the cutting-edge energy research from across UW-Madison and beyond, and to showcase how different disciplines understand energy challenges and develop solutions. So throughout this series, you'll hear from experts in science and engineering, as well as social sciences and humanities, to learn about the ways in which they view sustainable energy challenges and solutions. The seminar is open to the public, but it's also a course for students in the undergraduate Engineering for Energy Sustainability certificate, as well as the Master's in Sustainable Systems Engineering. And starting this semester, we're offering this seminar only online through Zoom webinar. And your registration for this webinar gives you access to all 7 webinars this semester. Live captioning is available for those who would like to use that feature. You can click the Show Captions button in Zoom to toggle that feature on or off. And if you have a question for our presenters, please use the Q&A. We'll have plenty of time for questions at the end, but we'll have our presenters get through their presentation materials first before we open it up for Q&A. And with that, I'll introduce, we've got 2 speakers today. So excited to share about the new research that's going on in agrivoltaics here at UW-Madison. First, we have Josh Arnold, who is the Campus Energy Advisor with the UW-Madison Office of Sustainability. And in this role, he is responsible for coordinating energy conservation, renewable energy, and strategic planning efforts at the UW-Madison campus. And working with campus and community stakeholders, he coordinates and implements energy efficiency and renewable energy projects that advance clean energy for people, planet, and shared prosperity. And he brings 20 years of experience in the sustainability industry prior to joining UW. And also joining us is Victoria Salerno, who is a research and project assistant with the Office of Sustainability and is working on the B Campus Initiative. Victoria is a PhD student in the Environment and Resources program, working with Dr. James Krall and Dr. Russ Groves. She is interested in urban biodiversity conservation, community science, and global change. And in addition to her work with the B Campus Initiative, her interest led her to her involvement with the Kaganza Research Station, which we'll be learning more about today. So take it away, Josh and Victoria.
Great. Thank you so much, Scott. And thank you so much to the Wisconsin Energy Institute and for having us as part of the Sustainable Energy Seminar Series. And of course, thank you to everyone who is attending online. My name is Josh Arnold. I work with the Office of Sustainability. And I'm the project manager for the Kaganza solar project, which we'll talk a little bit about today. I'm excited to kick off the webinar today, and then I'll hand it over to Victoria, who will share about her research. And as Scott mentioned, we'll have some time at the end to share, to hear about your questions and have some discussion. So first, let me start with a little bit of the big picture in Wisconsin. Our students, staff, and faculty, including many of the people viewing this webinar, are passionate about bold climate action. And they know that producing electricity using renewable energy, such as solar photovoltaic, is an important part of Wisconsin's net zero emissions future. The transition from fossil fuels to renewable energy is underway. In Wisconsin and all around the world, choices are being made about where and how we should build the energy systems of the future. The pace and the scale of this transition is happening quickly, and its impacts ripple across the landscape. This challenge prompts us to consider what and who we prioritize in Wisconsin's clean energy transition. Agrivoltaics is a win-win solution where solar arrays are planned for multiple uses in the same location. According to the U.S. Department of Energy, research in dual-use technologies such as agrivoltaics broadly supports the goals of improving affordability, performance, and value of solar technologies and establishing a domestic manufacturing base. Optimizing site selection and solar array design for energy production and agricultural production at the same location can reduce soft costs such as timing and costs associated with solar permitting. It can also enable stakeholders to more fully consider trade-offs, thereby leading to better outcomes. And these outcomes that we're looking to try to achieve would help us sustain Wisconsin's agricultural tradition while powering its clean energy future. You can see on this slide different examples of agrivoltaics and ecovoltaics. And the state of the industry is rapidly evolving. You'll see agrivoltaics where there are crops planted together with solar arrays. Also ecovoltaics where pollinator-friendly habitat is connected with solar arrays. There might also be grazing of sheep or other types of animals. In fact, there's more and more research going on for large livestock grazing. All of these solar arrays can combine agricultural activities and ecosystem services activities and have the potential to offer many benefits, such as increasing the efficiency of land use, sourcing electricity locally, creating green jobs, and diversified revenue for farm operators and local communities. From my own personal perspective, all of these examples, whether it's agrivoltaics, ecovoltaics, solar grazing, or other terms, all of these could be part of the Badgervoltaics community of practice, because what we're looking to do is look into agrivoltaics with the Wisconsin idea top of mind. Since 2015, the U.S. Department of Energy has supported agrivoltaics research through the INSPIRE program. INSPIRE stands for Innovative Solar Practices Integrated with Rural Economies and Ecosystems. A report from INSPIRE highlighted information collected from over 25 sites across the United States, and it organized itself into 5 C's of agrivoltaic success. Those 5 C's that you see on the screen were the inspiration for our Badgervoltaics community of practice. When you look at the logo for our Badgervoltaics community of practice, which you see on the screen, each one of these 5 circles around the W stand for one of these 5 C's of agrivoltaic success. And those 5 C's are collaboration, climate, configurations, crops, and compatibility. Today, I'm going to speak mostly about collaboration, because our Badgervoltaics community of practice brings together students, researchers, and industry professionals who share an interest in how solar arrays can be co-located with land uses that enable us to have innovative business practices, agricultural production, or ecosystem services. Innovative practices could include developing farm equipment or techniques for dual-use solar arrays, hosting educational tours, allowing for recreational uses, or other means that create value to the landowner and/or the community. Agricultural production, for our purposes, may be broadly interpreted to include crops, horticulture, hay, or livestock production. Ecosystem services generally includes land use practices that help improve long-term soil quality, water quality, biodiversity, and planetary health. Speaking of collaboration and partnership, the Badgervoltaics community of practice would not be possible without the contributions of many smart people on campus and in the community. We are especially grateful to our industry collaborators who share information and help us form research questions for us to explore. You can see examples of some of our industry collaborators on this slide. These questions help our group decide where to conduct field research at a growing network of statewide locations, which are also featured on this slide. Today, I'll share more about our work with Alliant Energy to develop a dual-use solar array at the UW-Madison Kegonsa Research Campus. The dual-use Kegonsa solar array is designed to be a living laboratory to further agrivoltaics education and research. And you can see some of the different groups that have been involved in this project for several years. We are grateful for everyone's contributions to making the project a success. Key activities that occurred during this process include a campus information forum held in April 2022, where students, faculty, and university leadership discussed potential research and educational goals and objectives for the array. Shortly after, in May, members of the project team visited the site and walked the location with the facility manager, the farming tenant, the utility, and members of the institution. All of this together, bringing everyone together like this at the start of the project is what we refer to as an integrated design visit. It helped our group have a common understanding of the goals and objectives for the pilot project and for our Badgervoltaics community of practice. The pilot project that I'm going to be talking about today is located at the UW Kegonsa Research Campus next to the Physical Sciences Lab located in Dunn Township between McFarland and Stoughton. It's about a 25-minute drive from campus, and it's about 10 miles or 16 kilometers away from the main campus if you're flying by helicopter. This slide is an early site concept of the pilot project, and it includes key reasons about where and how we sited the array. The solar array is located on 16 acres of a larger 280-acre research campus located near the UW Physical Sciences Lab. And you can see some of the reasons why we chose this particular location. It's an interior parcel, which helps keep it out of sight for some folks, in addition to keeping it shielded from views of neighbors where requested. It's also a south-facing slope, which is ideally suited for solar. The 16-acre portion of the location will be used for solar, but the rest of the location will continue to be farmed as before. This location is proximate to the Physical Sciences Lab, so we're able to work together with folks at the Physical Sciences Lab who are very interested in this project. And most importantly, we conducted an environmental impact assessment early on in the project, which resulted in a finding of no significant impact to people, wildlife, or the immediate environment. This design drawing of the array shows how the design of the array evolved over time. And the Kegonsa array reflects an innovative public-private partnership between UW-Madison and Alliant Energy. It is part of Alliant Energy's customer-hosted renewables program, in which Alliant Energy partners with customers to host an Alliant Energy-owned solar farm in exchange for a monthly lease payment. In our case, Alliant Energy and its subcontractors build, own, operate, and maintain the facility. Clean energy is delivered to the Alliant Energy distribution system, helping to power local homes and businesses. Renewable energy certificates from the project will be retired, bringing our institution closer to our clean energy goals while bringing our students, staff, and faculty closer to clean energy. UW students, faculty, and staff will be able to use the facility for education and research purposes. And at the end of the operational life of the array, the solar modules, racking, and electrical equipment are designed to be able to be removed so the area can be repurposed. And this process is called decommissioning. In addition, we'll be able to use the array as a demonstration to the public and our students for tours and events. This image is an aerial image taken of the array just after Thanksgiving last year. It shows all of the modules in place, and work continues at the array as we speak, and the array is expected to be energized later this year. The array is 2.25 megawatts AC, 2.87 megawatts DC. It will produce the electricity equivalent of about 450 or 500 Wisconsin homes. The solar array features 5,424 bifacial solar modules. These bifacial solar modules capture sunlight on both sides, and that helps enhance energy production. This is particularly effective in the winter as it capitalizes on sunlight reflected from snow. The array features 3 distinct types of racking and various spacing between the rows of solar array, which helps facilitate research, education, and demonstration. In addition, the array is designed to accommodate a multi-season recreational trail used for hiking in the summertime and snowmobiling in the winter. There are 2 different seed mixes planted at the array. There is an internal seed mix that's located within the boundaries of the solar panels, and that's a native seed mix. Around the perimeter, a slightly different seed mix will be planted, and that features also native seeds and with a pollinator seed mix around the perimeter. The idea for this project started in 2021. And since that time, we've worked with a number of campus and community stakeholders to inform the design of the array and to go through the various steps to not only get permission to build the array, but also to develop a research agenda for research and education at the array. Construction for the array was initiated in September of 2024. And as I mentioned, the racking and modules were completed in November 2024. The array is expected to be energized this spring. And this summer, we expect to have an opening where we'll be inviting our staff and students and faculty to the array to celebrate its success. Some of the proposed activities that we have planned at the array include feedback. The topics that you see on the slide here are based on feedback that we've heard from stakeholders over the last couple of years. So these include demonstrating innovative products such as farm equipment, forage trials for solar grazing, looking at the long-term impacts of soils and water and microclimate, looking at agronomic productivity, so looking at how plants interact in the solar array, looking at pollinator monitoring, which is what Victoria will talk more about in a moment. Also monitoring wildlife and birds. We'll have some of our engineering students and faculty monitor electricity production at the array. as well as we hope to be able to support a horticultural demonstration near the array as well. As I mentioned, we hope to be able to have the array open for class visits, tours, and events later this summer. We expect that the research and demonstration and education actions will continue to be developed over time. And the goal, of course, is just contributing to a greater shared understanding about agrivoltaics and potential applications in Wisconsin. I'm getting towards the end of my time. I'll be handing it over to Victoria in a moment. Just want to leave you with agrivoltaics resources. This slide includes resources not only from groups in Wisconsin, such as Renew Wisconsin and Clean Wisconsin, but also national and international resources for people who might be interested in exploring this topic further. These are the types of topics and resources that we discuss in our Badgervoltaics community of practice. So we have events and activities that help our community explore this rapidly developing field. It's informal, we have discussions, and we welcome all levels of interest and experience. If you're interested, please get in touch, and we'd love to have you as part of our Badgervoltaics community of practice. You can get in touch through the QR code or contact myself or Victoria at your convenience. And now it's my great pleasure to hand it over to Victoria Salerno, who will share about her work.
Thank you very much, Josh. As Josh mentioned, my name is Victoria Salerno. I am a PhD student in environment and resources, and I'm working at the Kegansa site, really interested in pollinator ecology. Overall, I'm interested in how global change impacts pollinators as not only model systems, but vital parts of our ecosystem. Before I start, I want to introduce us to the term planetary health. You may be familiar with this, but how I'm going to define planetary health for this talk is the integration and the interconnected nature of the environment and humans who use the environment as a resource and a place to live and thrive in. And when we think about planetary health, we have to think about how our global landscape is changing through multiple different factors and dynamics, including climate change, shifts in our biodiversity, how we use our land, including how we input and put chemicals within it, as well as how we change our spaces through urbanization and intensifying agriculture. And when we think about these sort of changes, we can think about how glyphosate may impact honeybees, one of our global pollinators, and also something organisms that we use not only for pollination, but also wonderful things like honey and other products. But we can also think about how pollinators in general are being really wiped out and facing decline through climate change in general and the way we use our landscapes. And so that brings us to agrivoltaics, or integrating solar within our agricultural practices as a way to mediate and mitigate the changes of the ecosystem on pollinators. And so when we think about pollinators, we are thinking about ecosystem services such as supporting general biodiversity, things that we like, such as flowering plants and the beauty we find in our surroundings, but also thinking as pollinators as agricultural inputs, as pollinators are not only providing over 80% of all pollination needs across crops, but providing pollination in general for all of the beauty that we find in the world. So understanding pollinators and agrivoltaics is a necessary step in order for us to understand and be very smart and integrated in the way we think about integrating agrivoltaics. So I've had the wonderful opportunity of working with Josh in the Kegansa site, not only through my coursework as an agroecology master's student, but also through a planetary health grant, in which I'm really looking to study and understand how pollinators and global change and agrivoltaics act as a way to mitigate these things. So I had the wonderful opportunity of presenting and sharing this knowledge, but this is sort of an overview of the work that I do, but I'm really interested in understanding how agrivoltaics impact pollinator dynamics. And so Josh has shown us multiple different schematics of the Kegansa site, But I'm showing you now what it looks like to be a pollinator researcher on an agrivoltaic site. So this is a schematic that mimics what we now see at the Keganza site, but also integrates how I look at the landscape in thinking about what we call line transect surveys. So thinking about how I walk the landscape in order to look at pollinators and understand their dynamics. And so when I'm walking a line transect, thinking that I'm following a straight line across a field, I'm really looking at abundance, diversity, and variation. And when we think about abundance, we want to think about how many of a certain species, so in this case, in the first image, bumblebees are found within a certain space. And then we also want to compare that against the diversity that we see. So how do the different organisms and the different diverse landscapes and different diverse populations integrate and connect to each other? And then how does that vary across different things? So in the case of the Keganza site, I'm interested in how does it vary against the different racking? So how does pollinators under a single fixed tilt vary differently from pollinators under an elevated fixed tilt? And now, one way we can do that is actually with bee hotels. And so if you're not familiar with what a bee hotel is it is a artificial habitat for solitary bees. Solitary bees are individual female bees, species of bees, that an individual female goes about her entire life alone. So when we typically think about bees, we might think about honeybees and bumblebees that live socially, but actually solitary bees make up 80% of all bee populations, and they are vital pollinators. So you can think of all solitary bees providing more, if not double the amount of pollination services that we see within honeybees. So I'm interested in using bee hotels, as seen in this top corner, to look at how bees are thriving under agrivoltaics. Now, the picture in the corner is what you might see in a traditional neighborhood or within traditional spaces within cities, but I am interested in introducing a very different looking bee hotel. And so you might see the picture with the red acrylic as something very foreign looking and very sterile, but actually it's a vital tool for understanding in-nest behavior of solitary bees. So if you see the picture with the blue bee hotel, you might be only able to see the entrance. So you can think of each individual circle as an individual home for a female solitary bee. And what I can view and what I can measure off of the blue bee hotel is the frequency of entering and exiting their home. Whereas with the red bee hotel, I actually am gathering a lot more information, and I'm able to look at the full lifespan of a bee from the time it is an egg within that individual house all the way to when it emerges as an adult and goes about its entire life. So I'm going to break down the red acrylic bee hotel for you, as it's a new technology that working with Josh has allowed me to explore and develop. So the first question might be, why is it red? And the answer is that bees actually cannot see or perceive the color red like we can. So this means that while I can see through the acrylic glass, you might notice the striation and the different pattern here that is actually individual tunnels, so individual houses for these bees, and we can see them, right? So we might expect that a bee might be able to see them or might perceive that space as being light, but in turn, bees, because they cannot perceive the color red, think of that entire cavity as dark. So we have the opportunity to capitalize on different biology between us and bees in order to sort of see and nest and examine what they're doing. And then I've had the opportunity to not only expand a bee hotel by being able to visually see into them, but I also have multiple camera setups that allow me to see and record these bees and look at growth and development and see who's actually nesting within a certain space. And this is important because we want to understand how not only certain species are found in abundance, but again, we want to see the diversity and variation across sites. So I'm looking to put each of these little units into different types of solar panels and sort of survey and do that line transect, seeing which bees are available and around. The other interesting thing about insects in general is that I'm able to use infrared lighting in order to also see and perceive what they're going on and what's going on and happening within these cells. And so this image in here in the pink box actually represents a top-down view of those nesting cells, allowing me to see and take pictures and be able to document really well how bees are thriving, existing under different solar panel types. And the importance of this is we want to understand how things like double-sided solar panels or the height and the different microclimates created under these solar panels influence bee development and diversity, and in general, how we can better support and understand pollinators. The more we know about the development, the more we know and can gather images and data, the better off we are to be able to plan solar arrays and be able to better support our pollinators. Thank you very much for your time, and I welcome any questions that you may have.
Great, thanks so much, Josh and Victoria. And please use the Q&A box if you have a question for our presenters. It looks like we have a couple, so I'll go ahead and read those off. So the first one asks, they're wondering if you might be able to share the reasons, both stated and unstated, explicit or implicit, for the opposition to solar projects in rural spaces. And could you say more about how Badgervoltaics will help address those issues?
Great, yeah. Thank you, Scott, and thank you for the question. Well, so I think there are a number of questions out there in Wisconsin related to Wisconsin's changing landscapes, and so while I'm not the expert in community concerns, I do know that there are some questions about there's people who are used to looking out over cornfields or soybean fields, and it's a big change if they are looking at solar panels instead of corn or soybeans. So there's a number of factors I think that go into community concerns about large-scale solar in particular. I do want to differentiate a little bit between large-scale solar and the type of project that we're talking about here today with the Kegonsa project. The Kegonsa project is on 15 acres. So while it's not a small project, it's also nowhere near the size of some of the larger projects that are causing a lot of controversy. So I do want to differentiate because the type of work and the type of design that we implemented at the Kegonsa location, while we feel like it was a very good fit for the specific location that we're working with at the Physical Sciences Lab at the Kegonsa Research Campus, it is not necessarily the case that you could just scale what we are doing at Kegonsa and scale that to 100 times the size or even 1,000 times the size. So our project is really designed to help people understand and help people have an opportunity to walk through a solar project and understand and see firsthand how agricultural practices or research, the type of research that Victoria is talking about, and other types of research can be implemented together with solar. One resource for the question about community concerns related to large-scale solar, the UW Extension program has a terrific website that has a lot of information about large-scale solar and different related topics as well. So so that would be a great place to look for more information about community concerns for large-scale solar.
Thanks. Next question. Kermit noticed that fixed tilt and single axis tracking panels were mounted at the Kegonsa site. Will this or future stages of this project experiment with vertical panel mounting, which has generated promising results in Germany, if they recall correctly?
Great question. Yeah, so we do have three different types of racking at the Kegonsa location. We have an elevated fixed tilt section, we have single axis trackers, and we have a standard fixed tilt section. We do not have plans to implement vertical array or vertical panels or vertical modules at this time. It just wasn't something that we had room to implement at that location. But it might be something that we explore at another location somewhere else. So it would be great to see that as the person who asked the question pointed out, they are being implemented in other places, Germany and other places in Europe. There's also an installation in Vermont that is just getting underway as well. So it definitely seems like it could be a really interesting opportunity, especially for commodity style crops where you have potentially long rows of crops and the potential to implement essentially almost like a solar fence or a solar windbreak in a location seems like a really interesting experiment. So I would also love to see that, but we don't have plans to do that at the Kegonsa location as of now.
Then a quick question from Bethany, who's actually a reporter for the Badger Herald. She was just asking if it's okay to quote the seminar for any reports that she does.
Yeah, Bethany, I think so. Yeah, that would be fine. And if you have any specific questions, feel free to reach out to me or to Victoria. We'd be happy to share more answers with you.
Great, thanks. And then Doug asks, what has been observed so far as to the effect of solar panels on pollinator success and behavior?
Yeah, so far the research and literature is pretty mixed about this. In some species, and this is what we tend to see with global change in general, in some species of bees, they actually really thrive under different conditions, such as the shade provided by solar panels, while we see declines in others. One species of interest, not a solitary bee, but bumblebees, one that's endemic to our region is Bombus impatiens, or the common eastern bumblebee. And within that, we've seen declines and also successes across these species of bees. So it's been very mixed, and it's really an area of research that we need to devote more time to in order to really understand. Largely, you can think that these trends of up and down tend to be colony or like individual based. We see a lot of variation across bees. But this mixed result really indicates that more dynamics need to be flushed out in order for us to understand. When we're thinking about solar panels, we're really thinking about the microclimates that they produce underneath it. So changes in not only shade and sun, but changes in temperature and wind patterns and vegetation really are big drivers of changes within pollinators. So we really need to devote more time to doing that. And that's why I'm so lucky to have this opportunity to engage in this.
And then another question just came in. What other experiments beyond the pollinator study will look at solar panels complementing or impacting grazing herds or other crop types?
Yeah, we do have a number of experiments lined up, and we're talking with researchers from around our institution and even at other institutions about how we can work together to support research and education at the site. So I mentioned very briefly about forage trials for solar grazing. We do have a group from UW Extension that is planning to, and I have some notes here because I'm not an expert in any of these things, but I'll just read it briefly. A group from Extension is going to be assessing biomass production and forage quality of different vegetation types targeted towards sheep. And they'll be including perennial shade-tolerant bunch grasses, sod-forming grasses and legumes. So the idea there is to do forage trials for solar grazing. We have researchers who will be looking at long-term effects of soil quality. In fact, we've had research teams out to the site even before construction began to be able to take baseline measurements of the location before construction even started. So we'll be having researchers looking at the long-term impacts on soil quality in that location. I mentioned looking at the water cycle, eco-hydrology, taking baseline measurements to monitor rainwater infiltration and depth to water table. We have a group that will be measuring impacts of the microclimate and looking at atmospheric changes with an eddy flux tower and a number of other folks as well. So lots of exciting things in the works. And another thing I just want to point out is that this project, we have a 25-year lease for this project with Alliant Energy and options to extend the lease up to 40 years. And so it may be the case that research or education that we're talking about now goes for some time, but we might also have students who want to explore other topics over time that we don't even know about. So the exciting thing is that we have a good amount of time to use this location and use it for research, use it for education and for demonstration.
Next question comes from Caden, and I'll just read it out. It's a little bit long, so if you need to repeat anything, let me know. So Caden says, to date, the US and Wisconsin in particular have struggled to effectively define agrivoltaics. Many companies use the term to articulate different project design aspects. What might the implications of a project like this be for, one, providing a statutory definition for agrivoltaics in Wisconsin, and two, utility scale solar projects looking to incorporate more agrivoltaic principles?
Wonderful. Great question, Caden. Thank you very much for that. Yeah, so as Caden points out, there are different interpretations for agrivoltaics and other terms that are out there besides agrivoltaics. There's ecovoltaics, there's agri-solar, there's solar grazing. And I think all of that sort of points to the fact that even though solar and agriculture have coexisted in places for a long time, this particular concept of agrivoltaics is relatively new, especially in Wisconsin, because you think about Wisconsin's energy transition, and most large solar arrays and the large projects have only come online in the last 4 or 5 years, 2019, 2020, when the first real big project opened up in Wisconsin. So I think there's still a lot of discussion happening in the industry in terms of what qualifies as quote unquote agrivoltaics versus ecovoltaics or other things. We have very robust discussions about that within our Badgervoltaics community of practice. So for me, I think it is important to have some general parameters, because we wouldn't want to be in a position where, let's say, solar developers are saying that a project is quote unquote agrivoltaic, but they're just using that term to try to advance permitting goals or other things that are maybe less than altruistic. So I think there is value in putting some broad parameters around what qualifies and what doesn't qualify. But at the same time, I think we're still in a kind of early adopter phase, where people are experimenting. And the Kagansa project is an example of that type of experimentation with agrivoltaics and ecovoltaics and other aspects as well. So I would say it might be a little bit early to think about a statutory definition or legislation, but at the same time, it is something where a lot of people are interested in this, and it would be great to have more support from government or other groups to help us better understand implications of some of these different design choices and construction choices when it comes to integrating solar with agricultural activities and research.
Yeah, Josh, I think as you said, this is a fairly new area of study, especially in Wisconsin, where other agrivoltaics research has gone on in other locations for a while. And I know in past events we've talked with others who've talked about the need for information on kind of the localized impacts of solar. And so maybe that's a good segue to the next question about is there research at other large commercial installations like what's being done at the Kagansa station?
Yes, there is fantastic research happening around the country and even all around the world. One of the really cool things that we get to do here at our Badgervoltaics community of practice is connect with researchers at other institutions and learn about what they're working on as well. So in particular, there's a really terrific array and research group at Iowa State University that also works with Alliant Energy. And so because we share a common electric utility, in the case of Alliant Energy, we've had a lot of wonderful discussions with our colleagues over at Iowa State University. University of Illinois has a very strong agrivoltaics program as well. And we've had wonderful discussions with researchers as far away as Cornell and Rutgers, Penn State, then over on the West Coast, Oregon State, Colorado State, and actually some of these pictures, this picture down at the lower center is a time when we had a peer exchange with the University of Arizona in Tucson, and we visited there in Tucson, and the folks over there at the University of Arizona were incredibly gracious to give us a tour of some of their facilities at Arizona, which Arizona in particular is one of the earliest adopters and leaders when it comes to agrivoltaics research. So we learned a tremendous amount from our colleagues down at the University of Arizona. And a lot of those communications and connections were facilitated through our communication with the National Renewable Energy Laboratory and their INSPIRE program. So that program, as I mentioned earlier, that's the program that did the research in the 5 C's of agrivoltaic success, among many other research. But that program has been an amazing connector for us to learn about what's happening in other places around the country, and for us to be able to help tell our story as well. So there's amazing work happening around the country. I would be remiss if I didn't give a big shout out to some of our local projects in Wisconsin that are doing amazing work as well. So Kagansa is not by any stretch the only agrivoltaics project even in the greater Madison area. Madison Gas and Electric has been doing really terrific work, working with sheep at the Tyto facility, Tyto Solar in Fitchburg, as well as our students are able to access the Madison Gas and Electric O'Brien Solar Project, which is also in Fitchburg, and we're able to work together with them there. So there's really terrific work happening across Wisconsin and across the country and across the world. And that resource page that I shared earlier has links to where you can go to find more information about projects anywhere you're interested.
Thanks. And just to follow up, do you know of other research efforts going on some of the larger solar installations in Wisconsin, like in Koshkonong? Not necessarily agrivoltaics, but just kind of the impacts of solar in general from these larger installations?
Yeah, with some of the larger with some of the larger projects, there's work done through the permitting process. So a lot of environmental impact assessments and permitting work. Those are featured on the Public Service Commission of Wisconsin website. They will have information about some of those big projects that you mentioned, like Koshkonong and Vista Sands and things like that. I should also give a shout out again to the UW Extension program. It's called Reset, that looks at siting for large scale solar. And you can find a lot of that information on the UW Extension website, Energy on Wisconsin. I don't know if I mentioned that part last time, but Energy on Wisconsin is a great resource from UW Extension, and that will get you a link to the Reset program, which really dives into details about large-scale renewables in Wisconsin.
Yeah, and I just posted a link to the Reset program in the chat for those who are interested.
Thank you.
Great. And then question from Ben, what challenges do you see for combining commodity crops like soybeans and solar PV for utility scale projects?
Yeah, so Ben, thank you for the question. Well, so when you think about commodity crops in Wisconsin, you're mostly talking about corn and soybeans. Primarily, but there's other things too, and I'm not the expert there. But when you think about, let's take corn as an example. While there are varieties of corn that are designed to grow not as tall, there's research happening in Purdue to look at that type of corn. Most of the corn in Wisconsin is pretty tall. And so when you think about combining corn with solar, the question comes about shading. So you'd either have to have panels at an elevated height, which is possible, but it's also more expensive to do. And so you kind of have to think about what's the trade-off between the added expense of elevated panels and how would that work when combining with corn. The idea of vertical panels, almost like a solar fence throughout commodity areas could be, I think, a really interesting concept. And as I mentioned before, I mean, I think there could be some really interesting applications for that. But I guess when it comes to corn, I think one of the major barriers is just going to be the shading issue and the potential added cost issue if you're thinking about elevated panels. So I think those would be some of the key concerns that I would think of initially when combining those two things. But this is a growing area, and as I mentioned, I think there is room to experiment with with different configurations and think about how to look into some of these options in greater detail. Soybeans are not as they don't grow as tall as typical corn you see here in Wisconsin, and so there's probably more flexibility that we could use with planting typical soybeans in and around solar panels. And so that might be something that we experiment with at Kegonsa or at other locations.
All right, well, I think we have addressed all the questions. But I don't know if you have any last words, either Josh and Victoria, that you'd like to share before we wrap up here.
I would just say, if you have any interest in getting involved or learning more, please scan the QR code. It's a great way to get involved. And of course, feel free to reach out to Josh or I if you have any questions or want to follow up on anything we've talked about.
Just to echo what Victoria said, we invite people to join our community of practice and get involved. And also just want to thank all the attendees for all the great questions. Thank you, Scott. Thank you, WEI and the Sustainable Energy Seminar Series for having us. This was a lot of fun.
Great. Thank you so much, Josh and Victoria. And we hope to see many of you for our next seminar in a couple of weeks. We'll have Professor Bernie Lacerte from Electrical Engineering talking about grid planning, operation, and stability. So I hope to see you all then. Thank you.